Okay, welcome everyone. Thanks for coming. This is week 2. So the week 2 webinar. And what I want to do is I'm going to share my screen so that you can see what's going on today and what we're doing. So let me share screen. And I'll talk about what's happening. Okay, so the plan today is always Q&A. So any questions you have, just post in the chat box or ask out loud, whichever one you feel comfortable with, and I'll be happy to answer. And that's at the beginning, but not just at the beginning. Anytime throughout the webinar, feel comfortable. That it's great if you ask questions and participate. And then after that, we're moving into chapter 3. So I think I mentioned this last week. Last week we had 2 chapters. And it was new. And this week we only have 1 chapter. And I'll let you know the 2 chapters combined are definitely not as hard as the 1 chapter. So just let you know, I want to give you a heads up that a lot of people struggle over this chapter. I do my best to explain what I can. The best thing you can do is practice, because you'll watch me do all this stuff. It'll probably make pretty good sense, actually. And you'll be able to watch it and say, yeah, I get it, I get it, I get it. And then you'll have to do a question, and all of a sudden it's hard because it's all kind of wordy. So I'm going to define what it means to say probability. Okay, you've all heard the word, but what is the mathematical definition of probability? And then after that, will I win $288 million this week? Okay, why do you think it's possible that I can win that?
You play the lotto?
Yep. Bought my tickets. I always do before class. And, in week 2. And do you think it's likely I'm going to win? No. My promise is that if I win, I'm going to build dorms for the college. Because I think that's what we need the most, is that it's so expensive to live in Tahoe. It'd be nice to have a place for students to live. But I don't have $288 million to spend today. Maybe next week. So we'll talk about what is the probability that I win. Okay. Then these sound really easy. The word and, right? You all know what and means, but it turns out in probability, it's a bit deep. And same thing with or. We'll talk about or, and there are going to be formulas depending on the situation for and or. And then given. Okay, that's also important. Then we'll talk about what it means for 2 events to be mutually exclusive. Okay, that one's not too hard. You just have to pay attention. Then we'll talk about what it means for 2 events to be independent events. And that one actually is a little deeper. But again, once you get used to it, it's not so bad. And then finally, and we'll spend pretty much time on this, by the way, is talking about Project 1. So Project 1 is not due for a while. I think you have like more than 3 weeks before you have to do Project 1. But you don't want to, procrastinate on it. You wait till the end and it's going to be bad for you. So again, that's why I want to explain it today, so that anyone who wants to can get started, like right after the lecture if you want. And I've noticed, which is great to see, a lot of you have posted on the Project 1 discussion board, finding partners. A lot of you have found partners. Make sure you find partners. Don't procrastinate that one away, or you won't have a partner, and then you pretty much can't pass. You can't get a passing grade on the project. So it's very important that you have a partner as soon as possible. You don't have to understand any statistics to find a partner. All you have to do is post on that Project 1 discussion board, I need a partner. And then hopefully someone replies, or reply to someone else who said they need a partner. And then hopefully they'll say, I want you as my partner. Okay, and best is for there to be 3 of you together. Okay, so if you only have 2 and someone says I need a partner, reply to them saying, hey, why don't you join us? And that'd be great. So that's important today. So we'll be talking about Project 1. So are there any questions about anything? Always happy to answer. Okay, while you're thinking or typing, I want to let you know that I spent a lot of today grading. Some of you might have noticed. So I graded the discussion post assignments. There were 2 of them. And definitely look at my comments. Kind of the number one mistake people make is not posting the initial post by Thursday. I'm not sure what I can do to make you do that. You have plenty of time between, you had plenty of time between the orientation or between the Tuesday and Thursday to post. That was quick and easy. And, but it's real important you do things on time. You do things late, I take off points. That's a guarantee. And then some of you didn't read the instructions and some of you didn't even reveal which one was your truth and which one was false. Some of you didn't talk about how you're going to use statistics in your future. So those are the kind of things that was in the instructions. So make sure that you read the instructions, and note that I always do a model post for the discussion boards assignments so that you can see the content, the kind of the items at which you want to make sure you've got in there. And don't just copy and paste what I've got, because what I have is a different article or whatever than what you've got. So that's important to look at too. So another thing is I recommend that before you officially post your initial post, see if you can answer your own post on paper so that you know that it's doable so that your classmates can answer it. Don't post what you did on paper because that's what your classmates are supposed to do. But if you can do it on paper and you can answer it, there's a good chance that it's a good post and you'll get full credit. Okay. And also, if you ever have questions, you can always ask me about it. Okay. And Braulio's around to help too a lot of hours. So you can email me, you can come or log into my office hours. You can log into Braulio's many hours. So we're here to help. Any questions? Any questions? Okay, if there's no questions, I want to just talk about probability. It's a word I'm sure all of you heard the word before. And I want to do some really easy ones first, because that gives you an idea of what things are and you'll get an idea of what the words are, and then we'll get into much more difficult ones. So here we have, I don't know if you can see, a coin. I'm going to flip a coin, look at it. What's the probability that I flipped heads?
50% chance.
Yeah, but what I want you to do, 50% is correct, but better is, I know you may not like this, but this is better for probability as a fraction. What's the probability?
Half.
I'm looking for a fraction.
0.5?
That's a decimal. 0.5 is a decimal.
Okay.
Yeah, 1 over 2. 1 over 2. Okay. So the probability, let me type this, and I want to show you how, when I type things, they look. The probability of heads is equal to 1 over 2. And the reason why it's 1 over 2, okay, again, I try to give a really easy one, but I want to look at it and really see those two numbers and understand them. So it's 1 over 2 because the numerator says that of the coin tosses, one of the sides is a head. And then the 2 is because there are 2 sides of the coin. Any questions on that idea? Looks easy, doesn't it? You're probably wondering, well, he said this was like a really hard chapter, but all he asked is what's probably getting ahead. And that was so easy. I want to start easy. Okay, so here's another example. And there's cards. Okay. And it's kind of sad, actually. This is a Mont Bleu, which doesn't exist anymore. They got bought out or something. I forget what they're called now. But this year they changed their name. So if I pick a card at random, what's the probability that this card is a spade? And again, you want to
1 out of 4.
Okay, yeah, there's 2 ways of thinking about it. I am going to write it as there are how many spades are there in the deck? How many spades are there in the deck?
There's 13.
Yeah, there's 13 spades in the deck, so it's 13. And then how many cards are in the deck?
52.
So a couple, you got this right. And by the way, that does reduce to 1 out of 4. It does reduce to 1 out of 4, but I want to write it kind of as the fraction that shows what's going on. And the 13 over 52 shows that there are 13 spades out of a 52 card deck. Any questions on that? Okay, so now I can talk about in general the big definition. And that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that occur. And in symbols, you can write P. P stands for probability. And then you go parenthesis A and parenthesis. And that's equal to, and then it's a number in A divided by the number in the entire set. Okay, it doesn't look too hard, does it? Okay, but what did I warn you about? All right, it gets hard. It gets hard. Start out easy. We're going to get harder and harder. Okay, so now let's do another example. Now what I'm going to do, I'm going to do the cards again. And I'm going to pick a card. Got it? And I'm going to take that card. I'm going to put it down over to my left. Then I'm going to pick another card. I'm going to put that over to my left. What is the probability that both of those two cards are kings? All of a sudden, it's much harder. Counting is too hard. Do you agree? If you looked at every single possible combination of two cards, we'd be here for hours. And I don't want to do that. Okay. Not that I'm lazy, but wasting my time and probably wasting yours time too. So instead, what we're going to do is we're going to use what's called the multiplication principle. So the multiplication principle says, write down the probability that this card, this first card, is a king. Okay, and that you probably can tell me. What's the probability the first is a king? Yeah, it's 4 over 52. So let's an equation, I think. Is it giving me my equation stuff? I have to do it this way, I think. Now I'll go insert equation. There. So now I can make a fraction. Since this is more complicated, I want it to look right. So it's 4 divided by 52. And then I'm going to multiply. We typically use the asterisk to mean times in a computer. Just let you know if you didn't know that. You could use X if you want, but if you've ever had algebra, you know that that's a bad idea because then there's too many X's around. Okay, so now what you do is you say, well, we want to say now that we picked our first card, and if we picked a king, because that's the only way to win, to get the 2 kings. And I put that down, and now I pick a second card. What's the probability that second card is a king? And the hint is it's not 4 out of 52 anymore. Yeah, it's 3 out of 51 because we've discarded one of the kings. So there's only 3 kings left. And we've discarded the king, which is a card. So there's only 51 cards left to grab from. So that's going to be 3 over 51. Okay, any questions on this? All right, now, again, you're always allowed a calculator. I'm hoping you're okay for me to just say now you stick it in a calculator. If not, tell me that you want to see it done in a calculator, but it's just multiplication. Any questions on that idea? All right, that was a little harder. Ready for harder? All right, so now, and by the way, I used to teach a class. It's been a while since I taught it, called the Mathematics of Poker. So I actually taught a class on that. It was a one-day class. We spent half the day going over mathematics of poker. And the question is, suppose that you pick 5 cards for a poker hand. So we're just going to do 5-card stud, they call it. Just going to pick 5 cards for a poker hand. So I got my cards. I go 1, 2, 3, 4, 5. And there's my 5-card poker hand. Okay. What's the probability of getting a royal flush? Now, again, if you don't know what poker is, let me explain. So a royal flush means ace, king, queen, jack, and 10 of the same suit. Any questions on what a royal flush means? Okay, again, it's not a requirement you know how to play poker, but I'm just telling you what's the probability of getting an ace, king, queen, jack, 10 of the same suit of those 5 cards. All right, so all of a sudden, this is going to be much more difficult. So the probability of the royal flush equals. Well, we know it's a fraction. Probabilities are always fractions, at least to start with. How many ways are there getting a royal flush? Here's a hint. One way is ace of hearts, king of hearts, queen of hearts, jack of hearts, 10 of hearts. Yeah, you could do it in hearts, diamonds, spades, or clubs. So there are 4 ways of getting a royal flush. That was easy. Now comes the much harder part. How many ways are there of picking 5 cards? And I want to remind you or let you know that in poker, the order at which you get the cards, if they just give you 5 cards, it doesn't matter. If you get ace, king, queen, jack, 10 of hearts, in that order, that's the same thing as getting ace, queen, king, jack, 10 of hearts. It doesn't matter the order you get it. We're just getting 5 cards. So how many ways are there picking 5 cards out of 52 cards? Any questions on that? All right, well, that's hard. Okay. So what we're going to do is we're going to go to the calculator. Okay. And again, the mathematics in office hours, I can show you, but I tend not to try to torture everyone with mathematics. It's pretty intense. But what I can do is we can do what's called combinations and permutations. So when you want to find out how many ways are there picking a certain number of items out of a larger collection of items where order doesn't matter, this is the calculator we're going to use. What is n? Any guess? I'm looking for a number. And it's 5. Good guess. It's the other one, though. Any thoughts? N is 52. So N is what you're picking from. And R is how many you're picking. So that's your 5. And by the way, it's very easy to do with the calculator. Without the calculator, this would be absolutely brutal if you had no calculator, in fact, if you had to do it by hand. And that will never happen in this class. I'm never going to take the calculator away from you. So then I'm going to calculate. CNR means order does not matter. PNR means order does matter. And with poker, I'm telling you order does not matter. And it's 2,598,960. So stop me if you have any questions on what I just did. So if you get out of a 5-card stud game a royal flush, should you be surprised? Or is that just normal?
Wait. So you just popped that into the calculator and that's how you got that number?
The 2,598,960? Yeah, I went to the calculator. I went to the combinations and permutations calculator. N was the number that you pick from. R is a number that you pick, and then calculate CNR. So I tried to make it simple.
I see. Wait, but the multiplication, the picking both kings, P parentheses both kings, would that work with the royal flush also? Like 20 over 52, 4 over 51, 3 over 50?
No.
That would not work?
I will tell you that. That's why I said that you don't want to do it.
Okay.
Yeah. So just go for the calculator. I could show you the math, but in office hours because I don't want to torture everyone else.
Okay, I got you. Okay.
Because it's long. Yeah, it's a whole big factorial formula. I'm just not going there. So the important thing is that if you're picking a certain number of things out of a larger number of things, then that's going to be permutations. Any more questions? Good questions. Okay, and I'm going to often, in fact, most of the time in this class, I'm going to tell you the math is too hard. There's a lot of very difficult math in this class that we just use the calculator for. Okay, this class, you do the basic math and you do a lot of interpretations. This class is all about interpretations. All right, so here's the next one. Is suppose that you guess randomly on a 20 question, 4-answer multiple choice quiz. Find the probability of getting them all correct. Okay. By the way, I don't recommend doing it because you probably won't do very well, but let's find out. What's the chance that you're going to just get 100%? On a multiple choice test, it has 20 questions and there's 4 choices for each question. So how do we do that? Okay, and this one turns out to be very different than the other examples that we did. Okay, so for this one, the idea here is that we're gonna first just think about the first question. What's the probability that you're gonna get the right answer on the first question? Yeah, 1 out of 4. There's 1 right answer and there's 4 total answers. What's the probability that you're going to get the right answer on the second question? Still 1 out of 4. How about the third question? Yeah, it's the same, all the way up to all 20 questions. Okay. So in particular, when we have this where we're allowed to repeat. So if you answered, C on the first question, well, the second question, you're allowed to answer C again. Does that make sense? Whereas with the card idea, if you got a king of spades for the first card, you can't get a king of spades for the second card. So that changes everything. So when you're allowed to repeat an answer, it's called with replacement. Okay. And when you can't repeat an answer, like the card deck example, then we just say without replacement. Any questions on that idea? When we have with replacement, then we know the probability of A and B equals the probability of A times the probability of B. Okay, note that this is when it's with replacement. And this is when they are what's called independent of each other. So because of that, we can say the probability that they're all correct, well, let's just do them 1 at a time. It's going to be 1/4 plus 1/4, times 1/4, times 1/4, times 1/4. You're going to write that down 20 times, but you usually don't, usually write ... And if you multiply the same number 20 times, that's the same thing as taking the 20th power. So I want to stop any questions on that idea. And it might be worth it to show you on a calculator, on this calculator, how to do it. So if I click scientific calculator, then one important thing is you put parentheses around the 1/4. 1 divided by 4. Close the parenthesis. And then we can do a power either hitting that button or hitting that caret button, which is Shift 6. Either way, you put 20. Any questions on what I just did? Okay, let me give you one more piece of advice that's really important. Is the probability approximately 9.09? Is that the probability? Definitely not. How come? Yeah, see that? 10 negative to the negative 13? That tells you got to move the decimal over 13 places. The first place is a freebie, and then you get a 0 each time. So you're going to have 12 zeros after the decimal point before you get to the 9. 0.00000000000000909. Okay. So by the way, if you ever have a multiple choice test that has 20 questions, don't guess at it and just hope that you got them all right, because it's just not going to happen. Again, these are tiny, tiny probabilities. Any questions on this example? Okay, I want to let you know that some calculators will have a times 10 to the negative 13, and some will just have that 9.094944702, and they'll put E negative 13. It means the same thing. So if you see E negative 13, that means times 10 to the negative 13. So again, depends on the calculator you're using. We'll let you know. Sometimes E, sometimes a scientific notation. It's kind of computer notation versus scientific notation. Okay, any questions so far? All right. So what is the probability, okay, that I'm going to be super rich, going to win the $288 million because I bought 2 tickets. So what's the probability that I'm going to win the Powerball? Okay, well, to know, what you have to do is you have to go to the lottery website, and let's read step 1. And what it says is, using a lottery play slip, you can find at any lottery retailer. I just use the nearby gas station, which nowadays gas is more expensive than buying a ticket, by the way. And you pick 5 numbers between 1 and 69 and 1 power number between 1 and 26. Got it? Okay. And then in a couple days, they're going to pick the numbers down in Sacramento, I think. And if their numbers match my numbers, then I win. Got it? So am I going to win? Shall we find out? Okay, so to find out, I'm going to go back and do some math. So we're going to pick 5 numbers between 1 and 69 and 1 power number between 1 and 26. And just let you know, in terms of the rules of the lottery, is that they pick numbers between 1 and 69, but if they pick 2 for the first number, for example, they can't pick 2 for the second. So that is actually without replacement from 1 to 69. But the 1 to 26, that actually can match one of your 5 numbers. So here's how we find it out. We find out how many ways are there of picking 5 numbers out of 69. So if I go to my combination, N is 69. and R is 5. And let's calculate. And I get 11,238,513. Yeah, so with Powerball, it doesn't matter whether they pick the numbers in your order or a different order. That makes no difference. In fact, when they show it online, they always put it, I believe they always put it lowest to highest. I'm not sure, but either way, order is not important. Yeah, so you don't have to worry about whether it was your order, as long as your numbers were picked. That's all that matters.
Does that number change if you hit the PNR instead of the CNR button?
Now let's check it out. Very much so.
Whoa.
Yeah, big, big difference. Yeah.
So the CNR is no order and the PNR is ordered?
Yeah. Yeah.
Oh, I
so
got it.
CNR means order doesn't matter. Right. And PNR means order does matter. So definitely going to do CNR here. Okay. And in this class, most of the time, we're going to do CNR. So then we just put it all together. I bought 2 tickets. So there's 2 different ways for me to win, right? Right? Either of my tickets can win. Okay. And they're different tickets, by the way. And then this 1, 1, 2, 3, 8, 5, 1, 3. And then I do times 26, because remember that there's the power number between 1 and 26. So that's that multiplication principle. Any questions on that? Any questions? Okay, so is that a good chance or a kind of low chance? Should you come to my house and rob me and steal my ticket? Because you might get the $288 million when you do that. Yeah, probably not a very smart idea. Okay. Yeah, so coming in and rob me just for my ticket is not a smart idea. And by the way, I don't have a lot of valuables in my house anyway. So you can rob me all you want and you'll be disappointed. Okay, there's not a whole lot you can get. Just let you know. I'm not one of those like that hoards valuable stuff. Okay, so any questions on winning the Powerball?
I'm sorry. How did you get the 2 again on the top?
Oh, because I told you about 2 tickets.
Oh, sorry. Okay, I got you.
So there's 2 ways for me to win.
All right.
Okay, and I always buy 2 tickets. That way in my class, I can always have not a 1 on the top so that I can answer that question. Because it's really important that the definition of probability is the number of ways you can win divided by the total number of ways of playing that can happen. Okay. Yeah, and this is, again, we're really talking about less than 1 in 100 million chance, if you work this out. So yeah, there's a good reason why I've never won this lottery, as in the grand prize. I have won the little minis. I spent my $4 and then I won $6, I think. So I have done that. But in terms of, the grand prize winning is really hard. And I don't expect to ever win. Okay, so here comes another question. Now comes a very wordy question, but these come up and it's really important to be able to handle these. Okay, so suppose, and I want to give you a heads up in our class. If I say suppose, what does that really mean?
Maybe.
Yeah, even more so. Means I'm totally making it up. Got it? So that means I just put in some numbers to make it easy for the class. Got it? If I ever say, Gallup poll showed that, then you can trust it. That means I actually, cited some reference. But if I say suppose, I'm just making up for the class. So don't quote me on the numbers here, because I don't know exactly what percentage of all students taking stats at LTCC are African-American. I really don't know. And that'd be a really hard one to find. So suppose 20% of all students taking stats at LTCC are African-Americans. 40% of all stats students at LTCC are non-STEM majors. Got it? If 22% of LTCC stats students non-STEM majors are African American, and you randomly pick a randomly selected African American taking stats, find the probability the student is non-STEM. So this is where a lot of people struggle. Any questions at all on the question? I think I want to pause so you can make sure you read it. Any questions at all on what this question is saying? Okay, so what we need to do is the following. We need to read this again, and every time we see a number, we need to write the symbols that that number represents. Okay, so 20% of all students taking stats at LTCC are African Americans. What is that 20%? That's a probability of something. What's it a probability of? You can write as a fraction, but you don't need to write as a fraction. Yeah, it's a probability of randomly picking an African American. Okay, this is the one time where you probably don't want to put it as fractions, or one of the few times. So we're going to say probability, and how about A for African American is equal to 0.2. So let's write that as a decimal. So any questions on that? Okay, then it says 40% of all stats students at LTCC are non-STEM majors. What's that? That's the probability of non-STEM. We need a letter for that. It's a good letter for non-STEM. Okay. Yeah, we could say N if you want. You can say S if you want. That's all up to you. Just got to make sure that you don't pick A because we've already got A. So make sure you pick a different letter than you've already picked. A bad letter for probability inside that would be P. I strongly recommend avoiding the letter P for any kind of variable. Another one that you might want to avoid are O. Do you know why? O looks like a 0. Okay, that's why, because it looks like a 0. We'll get to sigma later. We're not even there yet. That's next week. Okay. Oh, that was last week. We did sigma. Sorry, we did take sigma. Yeah, so yeah, you don't want to use sigma or mu, but you wouldn't anyway. No one uses Greek. But probability of non-STEM is 0.4. Any questions on that? Okay, if 22% of LTCC stats students non-STEM majors are African American, what's that the probability of? Yeah, that's non-STEM and African American. So we're going to write that as A and N. Okay, you can write A and D, you can use a symbol, however you want. Whatever looks good to you is fine. And that was equal to 0.22. Any questions on that? Okay, find the probability that, you pick a randomly selected African American taking stats, find the probability that student is non-STEM. So that one I'm going to have to explain what this is. The way I'm going to write it in symbols is we want the probability of being non-STEM, but we're only picking out of the African Americans. So we're going to say we're given that someone's African American. Now what's the probability that they're not STEM? And the way you write given is a little vertical line segment. So it's going to be P of N given A. And let me just, in quotes, that's the probability of n given A. Any questions so far? Okay, so now what we're going to do is there's a very important equation, and that is the probability of n given A is equal to the probability of n and A. Actually, I need to, we'll write that second, but I want to make it pretty with the fraction. Probability of n and A, and then divided by the probability of A. So I'm going to make this red and bigger because it's an important formula. Any questions on that? Okay, so that's going to be equal to, now we just do it because we have it. And one good thing about n and A versus A and n are the same. Do you agree? I've been to Nevada and Kansas. Do you know for sure I've been to Kansas and Nevada? Of course. Doesn't matter what order I said it in. Okay. On the other hand, given matters. Yeah. So the probability of n and A is the same as the probability of A and n, and that is 0.22. And then the probability of A is 0.2. Any questions on that? Okay.
The answer as it is now, is that acceptable?
Oh, wait. Probably of, wait, did I make a mistake here? 20% all students are African American, 40% non-STEM majors. I think I have this backwards somehow, or maybe I have a typo. I'm just worried about something. Just a minute before I answer your question, I'm worried about something. Let me read this. If 20% of LTC students non-STEM majors are African American. Yeah. I know what the problem is. This is not probability of A and n is 0.22. This is the probability of A given n. I knew I made a mistake. I knew I made a mistake because you can't get 0.22 over 0.2 because you get a number bigger than 1. It's a good check. It's kind of good that I did this so I can tell you, you should never get a number bigger than 1. You know you made a mistake. So probability of A given n is 0.22. Okay, so we can say, let's do some more. Probability of A and n, which is the same thing as n and A, is equal to the probability of A times the probability of n given A. So there's another important formula. How did I get the second formula from the first? What did I do? Basic algebra, that's a hint. What I do, yeah, I multiplied left and right by probability of A. Okay. That is equal to, well, probability of A is 0.2 times probability of
What is the 0.2 from?
n given A. That's when we don't know yet, right?
I got it.
Huh? But what we do have is the other way around. Is we can also say, because A and N can be switched, and we could do the probability of A and N is also the probability of N times the probability of A given N. And those both work. And probability of N now was 0.4. And the probability of A given N was 0.22. So that one we know. And then we could just finish it off. And we can say, what is the probability of N given A? Well, that's the probability of N and A, which is 0.4 times 0.22. Oops. Divided by the probability of A. The probability of A was 0.2. And there's our formula. Any questions on that?
I'm so lost. I can't even ask a question.
Yeah, it's kind of messy. I warned you, this is like the hardest part of the whole class right here, as in most people don't get it. So maybe I'll go through it one more time. Okay, so the idea here is let's one step at a time and stop me if you have a question on it. Probability of A is 0.2. Everyone okay with that? 20% of all students are African-American. Okay, probability of N is 0.4. 40% are non-STEM majors. Good with that? Okay, now if 22% of the non-STEM majors are African-American, so that's, if we're told they're non-STEM, then the probability of being African-American is 0.22. So let me stop for a second because that one's harder.
So that's
That's kind of
African
newer.
Americans, given that
questions
they
on
are
that?
non-STEM.
Yeah, so given non-STEM, of the non-STEM majors, 22% are African-American. And the way you write that is P of A given with that vertical liney thing, N. Okay. So then we have this big formula. Is the probability of something giving something else is the probability of both divided by the probability of what was been given. That's a formula. And that one you should not know, but you should maybe understand, maybe have it in your notes. Okay. And the letters don't matter. If it's a probability of Q given L or something, that would be the probability of Q and L divided by the probability of L. So there's nothing special about the letters N and A. So the probability of N and A, we don't know yet. So we had to do some work. We weren't able to find it that way, but we were able to find it this way. So the probability that an African-American is non-STEM is greater than the probability the student is African-American. An African-American is non-STEM. Yeah. Okay. And I just made up the numbers again. So again, these are made up numbers. Don't quote me on any numbers, but I wanted you to understand how to turn these into things. Okay, so we can take the probability of A and N, basically use this formula, but in the other way and say that's going to be the probability of N times the probability of A given N. Very similar to when I picked the cards and I said 2 kings. So I said the probability that the first was a king, that was, remember, 4 out of 52, times the probability the second is a king given the first is a king. And that was the 3 over 51. So that I use that formula.
Is this last, the thing that you highlighted,
Mhm.
is that from, now do I pluck that? Did you create that from the formula for P parentheses N given A? Like,
Right. So the idea is you can take this. This is basically a formula. You could either learn it this way or you could learn it the fraction way.
gotcha.
Doesn't
Okay.
matter how you learn it. And remember, if the A and the N are switched on this first line, that would be P of A given N is a probability of A and N divided by probability of N.
Okay, I gotcha.
Multiplied by probability of N.
Okay.
So again, the warning was this is the hardest part of the whole class for most people. So by the way, if you can't understand this completely, don't drop the whole class. It means that you'll get one problem wrong on one of the tests. Okay. No guarantees you get all the rest of them right, but this is definitely where people struggle the most. Okay. Any questions? Any more questions on this? Okay. So then I just took this and I just plugged it in.
Sure. So in the equation that where your cursor is at the bottom there, it's fine. So you have both P and in quotes N and P A given N also. So
this is a multiplication.
Right, I understand.
If you want, I can put a times there. That helps.
Oh, okay. So you have to have both of those, not just P, yeah, A given N. You have to have both the.
Yep, to get the and.
Okay.
The and formula has one of them times the other given the one that you know.
Okay, because it just logically, it seems like if you do, the second one, that it reflects the initial question, but that's not the case.
Right, because the case was we wanted N given A, not A given N.
Oh.
And that's different.
Okay.
You see that?
Yeah.
Very different. Yeah, you don't get the same number actually.
Okay. Thanks.
Yeah. Okay. I think I want to move on. I can only spend so much time on this. Okay. Let's see how much time we have. Yeah, we can do a couple more examples. Again, I just want to do a few examples because I think examples are everything. If you can't do examples, then you're not gonna be able to do anything basically for this chapter because it's all you're doing. You're just solving problems. So suppose you roll two 6-sided dice. Find the probability of the sum of the dice is a 5. Okay. So how many ways are there of 2 dice landing? No. All right, let's do a different question. How many ways, if I just roll 1 die, how many ways are there of it landing? 6. Okay, there's 6 ways of it landing. So that means the first die has 6 choices. For every one of those 6 choices, the second die has 6 choices. And that gives us a total of 6 times 6 for the total number of landings that could happen. Did I lose anyone there? Any questions on that? All right, now, okay, because you can get, let me just list them out. That'll help. I'm not going to list them all, but I'll list them until you realize it. It's going to be more. You get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. You get a 2 and a 1, a 2 and a 2, a 2 and a 3. You see, I'm going to be there a lot longer than just 12 times. So that's 36. How many ways of a sum being a 5? So you just list them out. You can get a 1 and a 4. You can get a 2 and a 3. You can get a 3 and a 2. And you can get a 4 and a 1. And that's all. So there's 4 up on top. Any questions on that? Okay, for time reasons, I don't think I'm going to do sum as a 7. I'm going to move to what's called contingency tables. All right, so here's another example. Okay, a lot of different kinds of examples. This is all one chapter, by the way. Whereas last week we did 2 chapters and I didn't have to rush as much even. Okay, so a survey was done. Okay, and by the way, I'm making this up. I don't know if a survey was really done, probably not. Asking LTCC transfer students where they plan on transferring to and what living situation there will be when they transfer. And this is called a contingency table. So you'll notice we have CSU, UC, UNR, and other. Those are the 4 different possible places they can transfer to. And by putting other, that means I've got them all. And similarly, where could they live? They could live in an apartment, they could live in their parents' place, or they could live in some other place. Any questions on that? Okay, so the first question is find the probability that a randomly selected student will go to a UC campus or live in an apartment. Any questions on the question? Okay, and then just to save a lot of time, if you add up all of these numbers, you get 246. Okay, and again, you can trust me on that. There's 246 if you add them all up. Just want to let you know, how do you read this table? So for example, the 19, there are 19 students who are transferring to a UC campus and living in another situation. Any questions on that idea, on how to read these numbers? All right, so here comes a big formula. And I'm doing it by example because I think that's the best way to understand it. Let's make it bigger. Too big. There. When you have or, then the probability of the first or the second is the probability of the first plus the probability of the second minus the probability of the first and the second. And the reason for that is if you add up the firsts and the seconds, then you might have double counted anything that's in both. And that's why you have to subtract off the and, because that subtracts off the double countings. So the probability of a UC campus, well, I just add them up. 33 plus 8 is 41, plus 19 is 60. So there's the 60 over 246, because we had 246 students. Probability of other, let's see, UC campus or
live in an apartment.
So I meant apartment, not other, I meant apartment. Probability of a UC campus or live in an apartment is what I meant. That's better. So probability of an apartment, call that A. Well, that's going to be 43 plus 33, that's 76, plus 19, which is 95, plus 22, which is 117. And it's still out of 246. And again, you're always allowed a calculator. I have fun doing this in my head. You probably don't. So use a calculator. Okay, when you do this addition. Okay, the probability of UC and A, that's just 33 over 246. Any questions on this or example? So or means either or. So both could happen or one of them can happen. And this formula always works. Probability of the first plus probability of the second minus probability of both the first and second. All right. Getting there. We're getting close. And then we got to do the project. That's why I want to make sure we got enough time. So a big definition is 2 events, A and B, are called mutually exclusive if the probability of A and B equals 0. And that makes them mutually exclusive. Okay, let me give you some examples just in kind of, not this example, but other examples. So let's say I randomly picked a person, and let's say A is an event they were born in California, and B is the event they were born in New York. Are those mutually exclusive? Definitely. You could not have been born in California and New York. Is that clear? Okay. Let's suppose I picked a person at random. How about a student at random? And let's say A is the event that they're currently taking statistics. And B is the event that they're currently taking an English class. Are those mutually exclusive? So A is that they're taking statistics. B is they're taking an English class. Yeah, the answer is no, because the probability of A and B in this case is not 0, because there are students that take English and statistics at the same time. So the numerator won't be 0. Do you see that? So are transferring to CSU and living with parents mutually exclusive? So very easy to check. So transferring to CSU and living with parents, notice there's 34 of them. So when I go to the probability, it's 34 over 246. And that's clearly not 0. So therefore, they're not mutually exclusive. Any questions on mutually exclusive? Most people find that one pretty easy. What people do, though, they forget to put in the calculation. And on a test, for example, I'm going to say, if it was a written problem, I'm going to say you must show the calculation. Okay, now comes another definition. This one's harder. So let me get it big. There. Okay, 2 events A and B are independent if any of the 3 are true. First, probability of A and B equals the probability times A times the probability of B. Second, probability of A given B equals the probability of A. And third, probability of B given A equals the probability of B. If one of those is true, they're all true. If one is false, they're all false. So if they're true, we say independent. If they're false, then we say dependent, by the way. Just to note, see this formula here? Only use it if you know you have independence. Okay, otherwise you got to use that given formula. Any questions on that? Okay, so.
Are there examples? Are there exercises in the textbook where we can practice this?
Oh, yeah. Okay. Yeah, textbook, homework. And then, of course, right here. So are living in an apartment and transferring to UNR independent. Okay, so we could check. Just let you know that the first of these 3 involves 3 calculations. Do you see that? Probability of A and B, probability of A, and then also probability of B. The first one's usually a little harder. So usually the second or the third are the easier ones, because that's just 2 calculations, and that one's also 2 calculations. Okay, so let's do the probability of A given UNR. So I'm going to go over here. Probability of apartment given UNR will be 19 divided by all the UNRs, because there's 19 that are of the UNR students living in an apartment, out of 19 plus 7 is 26, plus 15 is 41. So it'll be 19 over 41. So if we're given UNR, it just means that we're going to look at just that column and ignore all the other numbers. And that's why it's 19 over 41. So 19 over 41, when I put it in a calculator, I got 0.4634. Whereas the probability of A, without the given, that'll be 43, and we actually did that one already. That was 117 over 246, because we did that one over here. And if you put that in a calculator, I got 0.475. Are those equal? They're not equal. If they're not equal, then we say that the events are dependent. They're not independent. Any questions on the definition of independent? Any questions? Okay, what I want to give you now is a secret word, which I just said. The secret word is independent. Okay, so that's the secret word for the secret word quiz this week. By the way, there's no, we don't have an orientation this week. So from now on, we only have one secret word a week and one secret word quiz, but make sure you do it by Sunday. You should all get this one right. I just type the word independent, and then that will give you the secret word. So what I want to do now is we're going to change gears. I'm actually done teaching any new statistics. And now what I want to do, it's over here, is go to Canvas. And what I want to talk about, if I go to the syllabus and I scroll a bit, and that's projects. Because now we're ready to understand project one a lot more than last week. So now I'm really going to talk about it. Okay. And I want you to ask questions if you have them as I talk. So, you know, it's fine to interrupt me, no problem. So the first thing, I'm going to just read some of this. For project one, that's where we are. Students will collect quantitative data. By the way, what is the definition of quantitative? Yeah, that means that the data are numbers. So what I recommend doing is write down your survey question and ask your partner the survey question. And if a number doesn't come out of your partner's mouth, it will not work. Got it? Okay. So you're going to have a bunch of numbers because your data will be a bunch of numbers. Got it? You're going to be using a computer to display each of the charts discussed in class. Okay. And then I'm going to click on this project one, because that gives you a lot of information about it. Okay, so here's project one. Think of a quantitative investigation. And I'm going to give you the step-by-step. By the way, what's the first step on project one, which a lot of you have done already?
Get partners.
Get partners. Yeah, that's step one. Step one is have partners. There's best is if there's 3 of you. 1 is bad, very bad. 2 is okay, but not great. 3 is wonderful. Got it? So get partners, really important. Okay. You're going to think of a quantitative investigation that someone might contract out to have done. I want to highlight this word here, might. You don't really have to have someone pay. But you have to pretend that someone would pay. Got it? Okay. So you have to identify who might contract you to do this survey. And if nobody would be interested in it, then it's not a very interesting survey and it won't work for your project. Got it? Okay. All right. Then, okay, so it says then go and perform, but let me tell you the next step, what I recommend, strongly recommend. Once you've thought of, and you means the, if we were in the South, I would have written it this differently. Okay. I would have said contract y'all to have done, the three of you. Got it? So you're working together as a team. So then what you're going to do, someone on your team should post on the Project One discussion board your idea. And you should write down what your survey question is on the Project One discussion board. And you should write down who your client is. So who's going to contract you. And you should write down how you're going to get your data. Okay, and for this one, the data, it needs to be a survey question of people. Okay, and it's getting easier and easier. Last year, this was a nightmare. Do you know why?
COVID.
Do you know how hard, exactly. Do you know how hard it was to conduct a survey with COVID around? Okay, you had to literally email people because I didn't allow you to be near anyone because I can't do that. But now we're allowed. Okay, so then you're going to go and perform this investigation, and you're going to produce a report as though you were handing the report to a person paying for your services. So you're going to have to go and survey people in this project. And that's really important. Okay. Let me read this. The purpose of the report is to make recommendations based on your findings. So be sure to make the recommendations throughout your paper. You can be writing a long paper. Okay. Make sure you include who's hired you and why. So the audience is going to be your client who's hired you. Okay. And remember, this is hypothetical. So it might be President Biden might be the one interested. Of course, that doesn't mean you have to go talk to President Biden. Be wonderful, be cool if you could. Good luck. But you can pretend that you're talking to President Biden. Got it? You know, and that's who you're giving a report to, whoever it might be. Okay. Any questions on this so far? Okay, you must include a description of the sampling technique that was made and how that technique was applied. And again, what you want to do is before you even conduct the study, you want to post on your Project One discussion board how are you going to decide who you're going to ask. Got it? You're going to either use, and I'm going to say this very quietly, simple random sampling, stratified sampling, or cluster sampling. Do you know why I whispered? Simple random sampling.
Don't do that.
Not just don't do it, but it's pretty much impossible. If you think you can use simple random sampling of people, think again. Good luck. You're going to first have to get, say, the name of every person in America. And if you think you can do that, you're dreaming. So I put that there to just remind you that simple random sampling is pretty much impossible. Okay. And in fact, random is impossible. Stratified sampling, on the other hand, is very doable. And so is cluster sampling. And I provided 2 links. I'll let you look at those that give you an idea, if you forgot what stratified sampling and cluster sampling are, what those are. Okay. And I wrote some examples and paragraphs in the whole bit. Okay. Any questions so far? Okay. Discuss any bias that may have occurred due to your sampling technique. Just to let you know, if you think there is no bias, think again. It is pretty much impossible to do a survey of people and not have bias. One typical bias, kind of the most common, is voluntary response bias. That's typical, but there could be many other kinds of biases. Okay. Any questions so far? Okay, and you got to practice that a little bit in last week's discussion post, if you remember. Okay, notice that bias involves a misrepresentation of the population. So the sample data will not represent the population data. Any findings of potential bias should provide a convincing argument why you think your sample is more likely to have either a higher or lower mean. Okay, so if, for example, if you decided to survey people on what their major was, or not what their major, sorry, how many units they're taking. Let's say you're surveying your population are students in LTCC, for example. And you realize that you're only surveying people with type O blood. Is that biased?
Yes.
Okay, one more guess. No. It doesn't make any difference what your blood type is on how many units you're taking. Does that make sense? Blood type and number of units you're taking is meaningless. There's no bias there. Okay. On the other hand, if you only surveyed, let's say, reentry students, that would be students, say, haven't been in high school for 10 years, and you asked them how many units you were taking. Is that bias?
Yes.
And that'd be yes. Because reentry students tend not to take as many units because they tend to have full-time jobs and they're too busy. Do you see that? Not all of them. There are some reentry students who are taking a lot of units. But if you look at students right out of high school, they're more likely to truly be full-time students and not have a full-time job, and they can do that. Doesn't mean all of them. Can you not ask a survey question and other data through observation? So if it's an observation, it has to be a one-on-one observation. But it's pretty hard to get quantitative data with a one-on-one observation. So let me give you an example of observation that can work. Let's suppose that you work at a restaurant and you want to find out what tips are given, what percent tip, what's the percent tip that people get at restaurants. Got it? Then you don't necessarily have to ask the person, how much are you going to tip me? What you can do is, since you work at the restaurant, when you get the receipt, now you haven't physically asked the person, but you've looked at the receipt and you know how much the person, what percent the person gave you. Does that make sense? So that would be an example where you can do it with observation, one person at a time, but it needs to be that way, where you're actually seeing the person. Any questions? Any questions on that? Does that make sense? Okay, you are allowed to email instead of speak. So if you're, instead of physically get close to a person, and I'm specifically saying this because some people are afraid of COVID. And if you're afraid of COVID and you don't want to be near people, then that's okay. But you need to contact people. You can email them, you can call them, that kind of thing. Okay. But there needs to be individual people. Okay. Any questions so far? All right. The next one is you're not going to understand why. This is going to sound a little weird for a few more weeks. And that is the variable must be quantitative. That's okay. And the sample size must be greater than 30. So the sample size must be greater than 30. That is because if you have a sample size that's not greater than 30 for quantitative data, and this is just a heads up on what's going to happen for the last half of the class and the course, that is, you have useless data. So I'm just telling you that. So that's why the sample size is greater than 30. So the question is, can you use social media? Okay, you can use social media, but you need to use stratified sampling or cluster sampling. Cluster would be hard with social media because you have to make sure everyone answers, which almost never happens with social media. But stratified sampling can work. So for example, if you stratified by race, then you would establish your quotas and you'd have to also ask them, what is their race? Then you would have to make sure that you get exactly what your quotas say they are. Does that make sense? So stratified sampling and social media can work together. Okay, so yeah, social media can work. But again, those are individual answers of people, and that's fine. When I said email, I mean, it could be Facebook or Twitter or whatever. I know a couple social media. I don't know them all, so don't expect me to understand them all. But yeah, you just have to ask individual people or have individual people answer with a number. Okay. And then a big warning, if you use the word random, you better convince me it is. And by the way, good luck, because random is impossible. Okay, in almost all situations. Just let you know. Okay, so here's what you have to include. So now we're going to say you've now collected your data, and you have, so you have a bunch of numbers. How many numbers should you have? Yeah, so the small, not 30 or more, just be careful. What's the smallest number of numbers you can have? 31. 30 is not more than 30. So 31 is more than 30. Got it? So you could do a survey of 30. That's possible. You could do a survey of 40 or 50. I don't recommend doing over 50 because then you're wasting your time. And I don't want you to spend all your time doing the sampling. I want you to spend your time writing, typing it out. So I don't recommend a huge, gigantic sample because that's just too much work. So 31 is fine, 35 is fine, that kind of thing. 33, since if there's 3 of you, then you each do 11. Look at it that way. Okay. So once you collect your sample, okay, then the next thing you do is you need to get your charts and your statistics. Just let you know, see this calculator here? You're not allowed to use this calculator. Okay. So I showed you in the orientation, I believe it was. It might have been it's either Monday or Tuesday. I don't remember which day. I showed you that there was another calculator we use. Do you remember that? And that was, if I go to project spreadsheet resources, if I use this calculator here and I go to this Google Doc pages, and I sent you here so that you can read this important thing. A lot of people have don't do this and then it doesn't work for them. Is when you go, you have to go to file, make a copy first thing, but you click on that. And I recommend that if you have a Gmail account, first log into your Gmail account and then click on it. It just makes it a little bit easier to deal with in terms of technology. Then you're going to go to file, make a copy, you're going to give it a name. And by the way, don't worry about any warnings. Give it a name and then make the copy. I'm not going to make a copy because I don't want another copy. I'd have too many, but you need a copy. Then you're going to take this guy. You're going to hit the backspace after highlighting it. You're going to put in your data. Whoops. And once you put in your data, it's going to automatically give you all of the statistics you need. Any questions on that? Just to note, a couple things. One is because stem and leaf is an important one, make sure that you ask a survey question where you have at least 2 digits as an answer. So don't ask someone, for example, I don't know, don't ask a survey question like, how many times have you been to Somalia? That'd be quantitative, but what's the problem with that question?
It's unlikely that anyone's been there more than 10 times.
Almost everyone is going to say 0. Okay. My guess is none of you have been to Somalia. Am I right? I never want to go there, but maybe you do, but most people haven't, and definitely not going to be like 30 times. Okay. what is the policy on IRB? What's IRB? Yes, I'm not sure what that means. Institutional Review Board. Oh, privacy stuff. So here's the deal, and this is important, by the way. Don't survey any children. Don't survey any children, and then you should be okay. Children are not allowed to be surveyed. There's all kinds of legal problems. Okay, if you just ask classmates a survey question, you're fine. This isn't a formal study like that. So the key is ask people you trust, and then you should be fine. Okay, but yeah, that institutional review board, the main thing, don't ask children. Okay, so please don't. And if I say it, then that means you can't get sued. I can't get sued. There's really no problem with that as long as you just ask people you know, that kind of thing. Okay, so if you're going to do like a scale, don't do a scale of 1 to 10, do a scale of 1 to 100. And that way you get 2-digit numbers. Got it? Okay, so if you can do the scale like that, make sure it's 1 to 100. So make sure you get nice numbers that have, 2 digits in them. There can be some 1 digit, but make sure there's 2 digits. Okay, if you ask people, no, it wouldn't be convenience sampling, not if it was stratified. Then it wouldn't be convenience sampling. Got it? Or if it was cluster sampling. And what are the typical clusters people use? Yeah, classes. So then you don't have to worry about an IRB thing. You're just asking people in a few classes that represent the college. So that keeps you safer, because you're right. You don't want to do anything dangerous. I do want to let you know if you're going to do like ask people or look at, let's say you were doing the receipt idea for the tips, then ask your boss to make sure it's okay, so you don't get fired. Okay, and that is important. Or if you're going to go to a store, ask the manager of the store. That type of thing. Any questions on that? So those are the kind of the important things. Again, this is not supposed to be 100%, statistically perfect. Does that make sense? This is supposed to be, understanding stratified sampling and understanding cluster sampling. It's not going to be perfect. And that's another reason why I say you're not going to make this random. Random's not going to happen. Okay. It's okay to have bias, because you can get points for saying what the bias is and interpreting it correctly. Okay. Important stats: minimum, mean. Variance really isn't used for anything. Sample standard deviation, that's important. Very important. And I'll explain that when I get back to the project thing. The median, the maximum, Q3, and Q1. Just let you know, all these down here are not part of the project. Confidence level, confident lower, upper, all this stuff. None of that's going to happen on this project. Z-score, that's going to happen. That one does happen. See where it says change this? The Z-score needs to be meaningful. So reasons why you use a Z-score: one is to decide whether you have an outlier. Do you remember the definition of outlier? You remember?
Isn't it like 2 or more, 3 standard deviations away, something like that?
Okay, 3 was for extreme outlier.
Oh, it was 2.
2 was for outlier. So you're going to look at the Z-score of the maximum, for example, and you can see based on that Z-score, is it an outlier? And by the way, if it is, check the next highest one. See if that's an outlier. As soon as you don't have one, then you don't have to go any lower than that. And then same thing with the minimum, and do the same idea. And then you can check for outliers. The other reason why you might use a Z-score is if there was an important number. So for example, if your survey was, how many hours of sleep do you get? or did you get last night? Okay. And if somebody said, and you might want to look at 8, for example, and find the z-score for 8 to see if what's recommended, which is 8, is unusual or not. Do you see that? Okay, so that's important. All the rest of them, IQR does happen. Mode could happen. And none of the others happen. So let me go back. You're going to be doing a histogram, a box plot, and a stem leaf. And again, it's in here. That's easy if your computer lets you do it. If not, then I have links to do it. And just let me go back. You can include other charts, but you must include histogram, stem, and leaf, box, and whiskers because of the kind of the 3 main ones that we looked at. If you find another one is useful, then you can use it. Okay. For each chart, you should discuss how the client is going to use the chart to make decisions. What decisions might the client make after looking at, for example, the box plot? And you got the box, which gives you that middle 50%. Well, after seeing the middle 50%, what decisions will the client make? Does that make sense? Okay, very important kind of things there. I'll let you read through all of this. Okay. You should list the summary statistics, but don't just list them. Don't define them. That's not important. Explain them to the client and discuss or make recommendations on decisions the client will make for each of these. This is important right here. Standard deviation is the most important for the whole project. You have to have a whole paragraph on the standard deviation. In that, you include, remember, standard deviation is about outliers. Z-score is about standard deviation, by the way. So is the empirical rule or Chevyshev's theorem, and that was in the chapter video where I talked about that. So it's also in the book, the empirical rule and Chevyshev's. One of those will, if empirical rule works, use it. If it doesn't, then use Chevyshev's. Okay. And then based on all of that stuff, what will the client do in terms of decisions? Just to note, this is a paper. So it should be written in paper form. There should be an introduction. There should be a body and there should be a conclusion. So it should be well organized. I specifically do not give you an example of a project because then what I found, I used to do that. And then what happens is that students just copy it and then you have a disaster. So instead, I give you all the things you should have. Okay. Typically, usually about 8 to 12 pages is a good project. Okay. If you think you could do your project in 3 pages, think again. Okay. Just a note, the spreadsheet. You should go to the spreadsheet and we have these statistics and you should copy and paste literally that column, those columns into the project. You have to do that. And that proves that you use the spreadsheet. So copy and paste it in. Similarly, copy and paste the histogram, the stem and leaf, and the box plot. So those should be in the project. Okay, so again, you should have an introduction, a body, and a conclusion. Conclusion should state the main things you found and the main things your client should do. Okay, kind of repeats what happened in the body.
Can we?
All right, just a note, and this is very important. Huh? What's that?
Can we submit it early for you to review so that we can make corrections?
Can I ask you something?
What?
Are you reading my mind?
Oh, good.
Guess what I'm about to say? I'm about to say you really want to submit a draft of your project to me beforehand and not 10 minutes before it's due, because I'll be asleep, by the way. and that's a waste. So there's a timeline at which you have to do that. So I'm going to give you a lot more than what you asked, actually, in terms of whether you like it or not. So let's look at the timeline. So the full timeline. Okay, the first thing is on the timeline is partners. And strongly recommend for the partners, that timeline was supposed to have already happened by my recommendation was yesterday. So if you don't have partners, worry. You got to get there. You're already late. Okay. Okay, the next thing I strongly recommend, and I recommend this within the next 7 days, is post your project idea on the Project One discussion board. Okay, and you want to do that by the end of the week. And then I will let you know whether it's going to work. I might say, wonderful, looks great. I look forward to reading it. Or I might say, looks pretty good, but here's 2 things you might want to adjust. Got it? Okay. What if you've been posting on Project One discussion board and no one's responded? Post some more. Let me ask you, since we got, let me look to see, does it say? There are 8 of you, 8 students. Are there any of you that don't have 3 people in your project group right now? Put it in the chat box. I'm helping you right now. See if we can find any. Any of you that don't already have 3. Hopefully you're all listening, because that's one way to find a partner is right now. Okay, so keep putting in the chat box. Aha, here we go. I knew there'd be one. Okay, guess what? You're finding partners. Okay, look in the chat box. You can find a partner. Because this is recorded, I don't call names out. Because there's privacy issues, but you can look at each other and now you can find each other. Got it? So that's another way of finding people is right now. Okay, so go find each other. And by the way, if you go to the inbox, then you can privately email people if you want. Okay, and through the inbox, just to note. Okay, you can also put in chat box and private, do it that way too with private messages. Okay. Okay, so again, partners, this week, get your project idea. And I'm pretty good. I'm not a procrastinator, by the way. That's something you're going to learn about me, right? How long did it take for me to grade your assignments for last week that were due last night? Right, 1 day. Okay, usually sometimes it takes 2. But just let you know, I'm not a procrastinator. I will get back to your post pretty quickly. Okay, so that's the next thing to do. Then, and let me pop in the syllabus, because this gives you the date it's due, so we can look backwards. Project One is due May 8th. That's a long time from now, right? It's almost 4 weeks from today. It's 4 weeks minus a day from today. So 1 week to get your project idea done. And then I would say 1 week after that to collect your data. Got it? And then you'll still have basically 2 more weeks. So then 1 week to write it up after you've collected your data. And then what I recommend is a week before it's due or so, maybe 4 or 5 days before it's due is fine. You send me an email. This is where email is more important, is better than any kind of discussion board. Send me an email with your project either attached or linked to it. If it's, say, Google Doc, you can send me a sharing link. Then it might take me a day or 2 to read it, because these projects are often long. Could be 10 pages of reading, and I might get 6 of them. And you can see that. That's going to take me some time. So that's why that's another reason don't do it the last minute. Then I will get back to you on usually a top 10 list or so, sometimes 15, sometimes 8, depending on the project. And I'll get back to you on items to be improved upon. Does that make sense? Kind of top items to be improved upon. Just want to let you know in here, it should say. So Larry will be happy to look at a rough draft of your paper. If you can bring or email it to him at least by Thursday at 8 a.m. before it's due. But I will read it on a first sent, first read basis. So if I get a bunch that got sent to me Wednesday at 11 p.m., it's going to take me a long time to read them all. Does that make sense? And you may not have enough time to actually address all the issues. So that's why I don't recommend waiting until that Thursday. I recommend like maybe Monday or Tuesday if you can. Then I'll make sure, you'll have plenty of time. Okay. I only read your draft once. I learned the hard way. I have had students just send it and resend it and resend it, resend it. I can't do that. So I read it once, but after I give you the feedback, you're able to ask me questions and you post those on the Project One discussion board. And that way other people will get the idea of issues that people have. Okay. When the project is due on Sunday night, that day, which was May, was it 8th, I think? It's in there somewhere, May 8th. I recommend not waiting until May 8th to finish it. Okay, it's a good thing in life to learn. If you have 28 days to do something, don't finish it on day 28, finish it on day 27 at the latest. And that way, if something goes wrong, that gives you a whole day to deal with it. Does that make sense? Okay, or maybe May 6th or May 5th. So I recommend, I accept it on May 8th, but if something goes wrong, it'll be a nightmare for you if you can't get it submitted. Okay, one note is that you are a partnership. You all get the same grade. Okay, so I read the paper. It needs to have all your names on it, by the way. That's important. Make sure all your names are on the project. And only one of you submits it onto Canvas. Okay. It's not the end of the world if more than one does, but I'll just read the first in alphabetical order that submits it. So if one of you submits it, that's great. One of you submits it, then what I do is I read it, I write comments, and I write it directly onto your paper using Canvas. And then you share my comments with your partners. Okay, and everyone gets the same score. I have a kind of a summary of the comments that I'll copy and paste onto each of your project submission stuff, non-submission. But the individual on-paper comments, that's just one. So that's the project. Today was a longer day, and I did warn you that project explanation days are longer. There'll be another one of those in a month or so when I talk about Project 2. So that this is one of the longer of the webinars, by the way. So this is kind of over time. So that's pretty much it. And what I'm going to do is I'm going to stop the share. And I'm going to stop the recording.